Question 4, it says the nucleus of radium-91 undergoes alpha particle decay to form a nucleus of radon. So alpha particle is your helium nucleus 2,4. Identify the proton number and nucleon number of the nucleus of radon. So with radium it was 91 and it was 226, so it goes to radon plus an alpha particle which is 2 and 4, so this must be 89 because 2 plus 89 makes 91 and 4 plus 222 makes 226. So we're going to get a proton number of 89 and a nucleon number of 222. Nucleon number, it's both the protons and the neutrons. And it says the half-life of radium-91 is 1,600 years. Determine the length of time taken for 87.5% of the radium to disintegrate. Well, if 87.5% has disintegrated, there is 12.5% left over. So we're starting from 100, and after one half-life you will be at 50. After two half-lives you'll be at 25, and after three half-lives you'll be at 12.5. So each one of these will be 1,600 years. 1,600, 1,600, 1,600. So you would get 4,800 years for that to take place. Then it says immediately after the decay of a stationary radium nucleus, the alpha particle and the radon nucleus moves off in opposite directions and at different speeds. Outline the reason for this observation. Well, it says it's a stationary radium nucleus. So your momentum before must equal your momentum after, and your momentum before is equal to 0. Alright, so your momentum before is equal to 0, and that's equal to the momentum afterwards. And what is that? It's the momentum of the alpha particle plus the momentum of the radon particle. So the one must be in the opposite direction. So your P alpha must be minus the momentum of the radium. So it's in other directions. But so we have though that your momentum is equal to mv. So it's going to be, if I just continue here, we're going to have minus the mass of the alpha particle times the velocity of the alpha particle is equal to the mass of the radon particle times the velocity of the radon particle. Now, because your mass of your radon particle is much greater than your mass of your alpha particle, your velocity of your alpha particle must be greater than the velocity of the radon particle to keep this the same, to keep these momentums the same. And the minus means that it's going in opposite directions. So should we just try and explain that again in a simple sentence? So momentum is conserved. We're going to have the momentum is conserved. So because different masses, velocities must be different, and they must be in opposite directions because the momentum, the P at the start, was equal to 0. and then outline why a beta particle has a longer range in air than an alpha particle of the same energy. Well, the difference between a beta particle is smaller, and it has only half the charge of an alpha particle. An alpha is 2 plus, and therefore there is less interaction with the air molecules, water molecules, especially water molecules in the air. Okay, and therefore they will go further. The beta particles also, they're smaller, they have the half the charge. They will also probably be moving quicker, because if they have the same energy, because the beta particle is a smaller mass, they're going to be moving faster, and so obviously also that will mean that they will be moving faster, and so will have a longer range. Okay, so again, 3 marks. You need to make sure that you put in enough points to explain your argument to get your 3 marks.